since all life eventually dies. Then what is the meaning of life? This question, you may have asked yourself on a sleepless night. And the answer you got was often silence. Some say meaning is something you give yourself. Some say living in the present is enough. Others simply wave it off. Why think so much? Just get through today first. But I want to tell you another answer. One that does not come from philosophy books, or from feel-good quotes, but from physics and evolutionary biology. The reason you ask this question is itself the answer. Wait, that sounds like a tongue twister. The universe has existed for 13.8 billion years, and in those 13.8 billion years, it never knew it existed. Stars burned for billions of years, with no one to witness them. Galaxies collided. Shockwaves swept across tens of thousands of light years. The universe roared on. Black holes swallowed everything, including light, including time. And all along, not a single consciousness knew it was happening. Then, about 300,000 years ago, an animal called human beings looked up for the first time. And at the night sky let out a puzzled sound. What is that? At that very moment, the universe's 13.8 billion years of loneliness began to crack. And today, as you sit here, asking about the meaning of life, you think you are asking about yourself. But in fact, what you are doing is the ultimate moment the universe arranged for itself after 13.8 billion years of evolution. Humanity's search for meaning is not some side topic at all. It is the universe finally asking itself, why do I exist? Have you ever thought about this? If a tree falls in the forest and nothing hears it, does it make a sound? This is not a brain teaser. It is one of the deepest cracks in physics. For the first 13 plus billion years, the universe was just like that falling tree. Hydrogen atoms slowly falling under the pull of gravity, while temperature and pressure built up inside stellar cores until they reached the critical point. Hydrogen fused into helium. Helium fused into carbon. Carbon fused into iron. Iron is the endpoint of nuclear fusion. It can no longer keep burning. So the star collapses under its own gravity and finally dies in a massive supernova explosion. At that moment, its brightness equals the total light of all the stars in the Milky Way. Yet no eyes ever saw that light. Physics does not need an audience to run precisely. The law of gravity does not slack off just because no one is watching. The speed of light does not slow down just because no one is measuring it. The universe is a machine, so perfect it is suffocating. Its clock runs flawlessly, but no one knows what time it is. There is a philosophical gap here that we often ignore. Something happening and something being perceived are fundamentally different things. A supernova explosion is an event, but when no consciousness receives that light, processes that light, and feels within something called awe, then the explosion has happened. But it has not been witnessed. It existed, but it was never known. The gap between those two things is farther than any interstellar distance. The universe took nearly 13 billion years to begin closing that gap. About 4.6 billion years ago, a cloud rich in heavy elements collapsed under gravity, forming the Sun and the solar system. Earth settled down in the habitable zone, about 150 million kilometers from the Sun. Not too hot, not too cold. Liquid water was able to exist. About 3.8 billion years ago, the first organic molecules appeared in the warm oceans near hydrothermal vents. And note this was not some mysterious force. No soul descended from the sky. It was purely chemistry. Carbon atoms can form 4 covalent bonds. That is the structural foundation for building complex molecules. Nucleotides can carry genetic information and copy themselves. Phosphate groups can store and transfer energy through hundreds of millions of years of trial, error, and elimination. Structures capable of self-replication survived, and those that could not disappeared. That was the starting point of life. Specialized cells for transmitting chemical signals. But when tens of billions of neurons connect with one another in an extremely precise way, when this network begins processing massive amounts of outside information in real time, something with no name in any physics textbook appears. Philosophers call it subjective experience. Scientists call it the hard problem of consciousness. Simply put, why do electrical signals in neurons produce the sensation of red? Why, when light hits the retina, do you not merely receive a 700 nanometer electromagnetic wave, but actually feel the warmth of red? From objective chemical reactions to subjective awe and wonder, that gap in between is something no one has fully explained to this day. But one thing is certain. It truly was crossed. At some point, an ancient human ancestor looked up at the Milky Way in the African night sky, and something rose within that went beyond the physical fact of, there are points of light. A strange curiosity. A quiet sense of wonder. A feeling of, what is that? I want to know. At that very moment, something that had never happened before in cosmic history happened for the first time. The matter of the universe grew an eye and turned to look at itself. We are not outsiders, standing beyond the universe and observing it. The carbon atoms in our bodies were forged in the core of a star. The iron in our blood comes from the remains of supernovas. Every breath we take is a gift from ancient stars. When we gaze at the night sky, it is not tiny dust looking up at vastness. It is the universe through the structures it evolved, gazing at itself for the first time. From a physics perspective, light is an electromagnetic wave with wavelengths between 380 and 780 nanometers. That is all. But the last time you watched a sunset, did you think, oh, 780 nanometers? Of course not. What did you feel? Some indescribable softness. Some memory suddenly resurfacing. Or even an urge to cry for no reason at all. Beethoven's Ninth Symphony, on a physical level, is only vibrations in the air. Yet it can make two strangers in a concert hall burst into tears at the same time, feeling a connection beyond language. That transformation is the most extraordinary power of human consciousness, turning cold physical data into meaning. Science studies how atoms change, how gravity bends space-time, how neurons transmit signals. These things are immensely important. They are the foundation of our understanding of the world. But human beings are born to keep asking why. Why am I here? Why does the universe exist? Instead of there being nothing at all? Does life really have any meaning? Many people think this kind of questioning is unnecessary. But try looking at it from another angle. The universe spent 13.8 billion years evolving from fundamental particles into stars, then into planets, then into life, then into consciousness. Once consciousness finally became complex enough, it inevitably began to reflect on itself. It no longer only asked what is out there. It also began to ask, what am I? And then, what is all of this for? This step was inevitable in evolution, not some accidental detour. Asking why is the final evolutionary form of asking how. Our modern struggle to search for meaning is not weakness, not sentimentality, not philosophy students moving themselves. It is the universe, finally speaking, asking itself, why do I exist here? There is a famous experiment in quantum mechanics called the double-slit experiment. If you fire electrons at a screen with two slits, with no detector present. The electrons behave like waves and pass through both slits at once, forming an interference pattern. But the strange thing is, when you place a detector and try to observe which slit the electron actually passed through, the electron immediately collapses into a particle, and the interference pattern disappears. The act of observation itself changes the outcome. Physicist John Wheeler pushed this logic to its extreme. He proposed the idea of a participatory universe. The universe is not a stage set in advance, waiting for actors to walk on. The existence of observers is one of the necessary conditions for the universe to become real. This view remains controversial to this day. Physicists are still far from reaching a consensus, but it touches a deeper intuition. What is the essential difference between a performance with no audience and a tragedy no one ever knows about? If the universe created countless magnificent wonders of 13, but no consciousness was ever awed by them, fell silent, or wept over them, did those wonders ever truly exist in the fullest sense? Or were they merely equations solving themselves? Verbs without a subject? Gifts that were never opened? When humanity appeared, when we began to observe, name, understand, and feel, that long cosmic loneliness truly began to fade. It is the universe's response to its own loneliness. That soft sigh you let out beneath the stars is the first syllable spoken after 13.8 billion years of silence. This also explains that faint sense of loneliness deep inside human beings. That feeling, as if we are searching for something greater than ourselves to reflect who we are. In fact, that is not merely a personal psychological struggle. It is loneliness on a cosmic scale, experienced through us, through this node of consciousness, in the form of an individual life. We are searching for our reflection in the universe, and the universe, through us, is searching for its own reflection. We are each the answer the other has long been waiting for. So what are human beings in the universe? The standard answer is rather discouraging. At the edge of the Milky Way, on a planet beside an ordinary star, there appeared, for less than an instant, a sighing form of life. On the scale of space, we are so small as to be almost negligible. On the scale of time, the history of human civilization is less than 1/1,000,000th of the age of the universe. That answer is not wrong, but it is incomplete. It leaves out one extremely important fact. Complexity is not proportional to size, and meaning is not proportional to mass. A single neuron is less than 0.1 millimeters in diameter. Yet the number of synaptic connections in the human brain is estimated to exceed 100 trillion, more than the total number of stars in the observable universe. We are tiny in space, but we are the most precise, the most complex known structure. That the universe has evolved over 13.8 billion years. More importantly, those magnificent stars, those spinning galaxies, those colliding galaxy clusters, the billions of times larger than us, do not know that they exist. Only we, sitting here on this blue planet, can raise our heads and, with trembling voices, ask, where did all of this come from? Why are we here? Every scientific discovery is a moment in which the universe comes to know itself again. When Newton wrote down the equation of gravity, it was the first time the universe understood its own workings through the language of mathematics. When Hubble discovered that the universe is expanding, it was the first time the universe knew that it had when Watson and Crick unraveled the DNA double helix. It was the first time the universe read the genetic code written into its own matter. Every one of those moments was not merely progress in human knowledge. It was the universe, through our hands, putting its own puzzle back together. So let us return to that first question. Since all life eventually dies, then what is the meaning of life? Perhaps the answer does not lie in what remains after death, but in what was witnessed while we were alive.